All right, guys, we're going to talk about remainder theorem, okay? And more specifically, hopefully you watched the video from Monday that talks about synthetic division. So what is remainder theorem? Basically, remainder theorem says we can use a process, a mathematical process, which in this case, the process we're going to do is synthetic division. Okay, so it's called synthetic division. And with synthetic division, we can quickly find out, do I have a remainder? Okay. It's all basically what we're doing. So if you look at this polynomial here, number 1, we are taking this polynomial and dividing x minus 2. Okay, so our divisor, the guy that's doing the dividing, if you notice, he's in what we called polynomial form. Okay, polynomial form. All right, so in order to do synthetic division, we want to put him in answer form. So to convert to polynomial form into answer form or solution form, it's simple. Okay? So before we can do synthetic division, what we are dividing by, if it's in polynomial form, we want to put it into answer form. So if you look, to put this guy into polynomial form, we have him in polynomial form. To put him into answer form, we simply take our polynomial, set equal to 0, and solve. And once we do that, it will give us answer form. So if we solve this guy, our answer form is 2. Okay? So this is what we kind of want to do before, actually we need to do it before we do synthetic division. So let me reiterate. Synthetic division is a way to find the remainder really fast. Okay? So to do that, instead of doing division, which is called long division here, we have this guy, the divisor, the guy doing the dividing in polynomial form. We want to turn him into answer form so that we can use synthetic division. Okay, to turn something into polynomial form, we just set it equal to 0 and solve. Something you should be comfortable doing. Okay, so my answer form of this polynomial is positive 2. All right, so how does synthetic division work? We want to set it up like this. Okay, so answer form of a divisor. So the answer form of the guy that's doing the dividing goes here. So if you look, it's 2. Not negative 2, it's positive 2. Okay? The next thing is we're going to put some numbers here. Okay? And where we get the numbers is from our guy being divided. So what we're looking at here is, I'm going to write this out. Okay? And the key here is that we have to put it in standard form. So that means we have to have every power in every order. So we start with the highest power, power of 2, power of 1, and then the constant. Okay? If you skip a power, we got to add that power in. And I'll show you what that looks like when we do number 3. Okay? So what we're going to do is look at our first term here of the guy being divided. What is the number in front, or the coefficient in front? So our power of 2 is 1. So we're going to put the 1 here. So think of this. This was the coefficient of the power of 2. Okay? So after a power of 2, we need the power of 1. The number that's in front of the power of 1, or the x by itself. And that number is positive 3. He goes here. So we have power of 2, power of 1. And the next guy is our constant, the guy without a power. We'll put C for constant. What's his number? He's positive 1. Okay? And how does this work? Very simple. Just got to remember the pattern. And most students are comfortable with this. Okay? So we're just going to look at these numbers. First thing you want to do is we're going to bring our first number down below the line. Anything below the line, we multiply with our answer form here. That's the divisor. So what's 2 times 1? The answer is 2. It goes into the next column. So positive 2. Okay? So now we're in the next column. We do the math. Positive 3 and positive 2. Combine these and you get 5. We're basically adding. They're both positive. We're going to add them. Okay? So now 5 is below the line. We're going to multiply with 2. 2 times 5 is 10. It goes in the next column. And then do that math. 1 plus 10 is 11. Okay? Since there's no more numbers, this last number is your remainder. Okay? So my remainder in this case is 11. And why is this important to find remainders? Well, we're going to talk about that in a little bit. But the reason this is important is because if you think back to elementary school, when you had a remainder, that told you that the guy you're dividing by, so in this case, we're really dividing by x minus 2. That tells me this guy we're dividing by does not divide it evenly. There's a remainder. Okay? The only time it divides evenly is when our remainder is 0. Okay? So this is how we use synthetic division. It's a quick way to find the remainder. All right, let's jump over to number 3. Let's set this up again. So again, this is in polynomial form. So this is poly form. We want to turn it into answer or solution form. Okay, and again, how do I do that? Take your polynomial form and put it equal to 0 and solve. So if I solve, x equals to negative 1. So negative 1 is answer form. Okay? So let's set this up. We're going to use synthetic division because I really want to find my remainder. Okay? So again, just like we did before, answer form goes here. Of the guy that's doing the dividing. So x plus 1 is doing the dividing, but we want the answer form. So it's negative 1. All right. And then we are going to go ahead and write down our polynomial. So our highest power is x to the 4th. So think of this as just notes right here. X to the 4th. You really don't have to put the x to the 4th. It's just my version of explaining. So the number that goes with x to the 4th is 16. But remember, here's the key. We have to have, after x to the 4th, we have to have x to the 3rd. If you notice my problem up here, there is no x to the 3rd, which means when we skip a power, like we're doing here, we got to put in a holder, a placeholder. So that placeholder is going to be 0. Then check, do we have an x to the 2nd? No x to the 2nd either, so that's also going to be 0. Do we have an x? Any x here? No x either, so that's also 0, but we do have a constant. Okay, so our constant is negative 1. Signs are important. Be careful. So this is what I'm talking about when we need to put it. Every single variable has to be accounted for, starting with the highest power, 4, 3, 2, 1, constant. So now we just do that process. Bring this guy down. He goes below the line. -1 times 16. His answer goes on the next column. That's -16. 0 plus -16 is -16. -1 times -16, +16. 0 plus 16 is 16. -1 times 16 is -16 again. 0 plus -16 is -16. And this last guy is going to be my remainder here. So -1 times -16 is +16. Do the math. -1 and +16, that is 15. So I have a remainder of 15. Okay? Which means, just like in elementary school, this does not divide this evenly. There's a remainder. All right. Let's move on to, that's basically how we're going to be using synthetic division. We're going to go further than that, but really for this section, that's basically what I want you to do. Find the remainder. Okay, that's synthetic division. All right, we're going to use the factor theorem. Okay, so in essence, we want to know, is this guy a factor? How do I know if this guy is actually a factor? So without actually dividing all this, to check if this is a factor, we want to use, again, synthetic division. Okay, so we're going to use synthetic division. And to figure out if it's a factor, this is called factor theorem. Our remainder should equal to 0. So in essence, we're going to do the same process we did in the last examples. But if our remainder is 0, that means this guy divides evenly. And that's the definition of factor. Can this guy divide evenly? The only way it can divide evenly if it's a remainder of 0. And this is called the factor theorem. So he is my divisor. We're going to check, can this guy divide? So I know it's a little different format, but we're checking, can this guy be my divisor? Can he divide evenly? Right now he's in polynomial form. We want to turn him into answer form. So we're going to go r minus 5 equal to 0. Solve for r. So we're going to add 5 to both sides. R equal to 5. So my answer form is 5. Okay? So let's do synthetic division. Here's my divisor and answer form. He's 5. And now we're going to go, starting with the highest power, it's r to the third. So r to the third, what's the number with r to the third? 2. We need r to the second, which we actually have, -15. We need r, which is +27. And then we need the constant, -10. Careful with your signs here. They're very important as we go through this. So let's go ahead and do synthetic division. Remember, our goal to check if this is a true factor, our goal is we want a 0 here. Remember, this is how I check my remainder. If it's 0, it's a factor. So keep that in mind. I'm just going to leave the 0 there. That's what we want. And we could go from there. Bring down the 2. Below the line gets multiplied with our divisor in answer form. 5 times 2, 10. -15 and 10, that's -5. We're just adding and subtracting there, depending on sign. 5 times negative 5, negative 25. 27 and negative 25, that's positive 2. 5 times 2 is 10. Negative 10 and positive 10, 0. Okay? Since our remainder is 0, that means r minus 5 factors evenly or divides evenly, which is a definition of factor. So we would then say r minus 5 is a factor because it divides evenly, and the reason we know it divides evenly is because we have a 0 remainder. Okay, so we'll skip 5 for now. We're going to do that same process for 5, but keep in mind when you do 5, look at the powers. You have power 5, 4, we're missing 3, missing 2, we have 1, and constant. So you have to add in zeros when we do this stuff, okay? Okay, guys, let's jump up to number 6. If you can understand number 6, this is exactly where we're headed. If you can do A, B, C in number 6, or at least understand it as I do it, then this is, I mean, you got it, okay? So let's go ahead and do number 6. Here's our polynomial function, all right? So it says verify that B, when I plug in negative 2, equals 0, okay? So think of it this way. It's basically asking you, hey, is negative 2 going to give me a remainder? Think of this guy as your remainder. This is the remainder theorem. Remember, I'm sorry, not the remainder theorem, factor theorem. Okay? It's just putting it in a different way of asking. Okay? This guy, negative 2, is our divisor. He's the guy we're dividing by, but he's no longer in polynomial form. He's already in answer form. Okay? So think of it that way. They're giving it in the reverse format. Before we had it in polynomial form. Now it's already in answer form. So we don't have to convert it. We're going to leave it in answer form. All right? Which means, in order to do this, we put our answer form here in the synthetic division. So what do we do in this problem? It says, if this divides evenly, it's already in answer form, we're going to divide this using synthetic division. If it divides evenly, which means we have a remainder of 0, so we're verifying that this is going to give me a remainder of 0 using synthetic division. Once we have that, I want to know those factors. Okay, so this is the next step I'm going to talk about. How can we find the factors using synthetic division? So real quick before I get into this, factors, remember, are always in polynomial form. So right now we're dealing with answer form. We got to turn it into polynomial form if it gives me a remainder of 0. Okay, so, and again, we're using the function b, so don't let this little variable over here mess with you. Just saying, I want to know the factors of function b. So let's go ahead and start. We have a power of 3. So w to the third power, it's the number in front of that. 2. W to the second power is actually, what's the number in front of that? It's negative 1. Then we need w to the first power, which we do have. It's negative 7. And then we need the constant, which is 6. Okay? So let's check this out. How is this going to work? All right, we want to verify that this will actually give me a remainder of 0. If it gives me a remainder of 0, then we actually have some factors because it divides evenly. So synthetic division says bring this down. Negative 2 times 2, negative 4. Negative 1 and negative 4, that's negative 5. Negative 2 times negative 5, that's positive 10. Negative 7 and 10 is positive 3. Negative 2 times 3 is negative 6. 6 and negative 6, 0. Okay, so that means we're going to have some factors. All right, so we're going to, in order to do this, we have just verified that this divisor is a factor. So what we're going to do is part B. I want to find all the factors. Okay, so we know that this is a factor because it's here, but it's in answer form. So what we want to do now is to find its factor. We're going to turn it back into polyform because all factors are in polynomial form. Okay, so if you recall, when we did answer form, it was x equal to, in this case, it's negative 2. Well, we want to reverse that. So basically, I want it equal to 0 now. So I'm going to add 2 to both sides. And we get x plus 2 equal to 0. Here's my polyform. Okay, so one factor is x plus 2. All right. But we have more than one factor. This is where this comes into play. Because it was 0, this is actually very significant. This is important. This is how this works. So watch. This is actually another factor. Okay, so we're going to put it in its own parentheses. So the number's at the bottom. This is how we're going to do it. We're going to put the number 2. Okay, and then understand. What was the power we started with in our original? It was a power of 3. Because we divided something out, it's one less power. So instead of a power of 3 here, we're going to do a power of 2. Okay, he started out as a power of 3, now he's a power of 2. Now the next guy is negative 5, and we just go down the line. Negative 5 instead of power of, so we go in order. Power of 2, what's the next power I need? Power of 1, we don't need the little 1 there though. And then the last number is positive 3, and the positive 3s are constant because we ran out of variables. So once you get the first guy from here, do 1 less power, and then just go down the line. Power of 2, power of 1, constant. So this is actually my factors, but as you can see, we can factor this guy. Okay, he's the quadratic pattern. The A value is 2, B value, C value. This guy is my snowflake method. Again, this is stuff we talked about last week, and we got to get really good at this because it doesn't go away. So A times C at the top, that is 6. B at the bottom, negative 5. Okay, our A value goes here and here. And then we split the W. W. Okay. And then we are going to go ahead and figure out what multiplies to 6 that adds up to negative 5. So what multiplies to positive 6 that adds up to negative 5? Well, that's going to be negative 3 and negative 2. Negative 3 times negative 2, positive 6. Negative 3 plus negative 2, negative 5. So now we want to reduce if we can. Can I reduce this? 2 and negative 3. Can I divide these? Nope. How about here? Yes, I can divide these by 2. Reduce by 2. This turns into 1w. This turns into negative 1. So now we have originally x plus 2. That stays. Then we're going to put this into our 2 factored form. 2w minus 3 goes here. 1w minus 1 goes here. This is all my remaining factors. Okay? Part C, state the zeros. What the heck does this mean? Remember, earlier I said in the previous week, zeros is the same as saying solutions, roots, means the same thing. So what are we really doing? We are splitting up our factors and using the zero product property. So we're going to take each factor and set it equal to 0. X plus 2, we've done this before, equal to 0. 2w minus 3 equal to 0. And then w minus 1 equal to 0. And all we're doing is solving. Subtract 2 to both sides. This gives me negative 2 is a solution or 0. Add 3. 2w equals 3. And then divide by 2. W equals 3 over 2 is a 0. And the last one is add 1. W equals 1. And then check. At our original problem, what was our degree? It was 3. How many answers should we have? 3. Okay? That's how you do number 6. All right, let's go ahead and jump over to number 7 really quick. Okay? So basically, think of it this way. In number 7a, they have given us the answers. They want us to turn it back into polynomial form. So what we're going to do is, think of it this way. These zeros are x equal to 5. This is in answer form, and x equal to negative 4. So answer form, let's turn it into, so hold on, let's put it this way. Answer form is there. Okay, we want to convert it into poly form because that's how we put it into function form. So poly form, which means polynomial form, if you look, we want to turn, like we did here, we want to turn these guys back into these guys. We're doing it in reverse. So in essence, we want this guy equal to 0. So what does that look like? X equal to 5, reverse it. We want the 5 with the x now. So poly form is going to be x minus 5 for the first guy. If you think about it, guys, we're in essence just switching the sign, if you really see that. And then this guy, x equal to negative 4, put it back, reverse it, get the 4 with the x, so it could be equal to 0. This turns into 0, just like this turned into 0. And poly form is x plus 4. Okay, so that's poly form, but we're not done. So our factors we now have is x minus 5, x plus 4. To get it to look like our original function up at the top, to make it look like something like this, we are going to multiply something you're comfortable with. So if I multiply x times x, x squared, x times 4, positive 4x, negative 5 times x, negative 5x, negative 5 times 4, negative 20. Combine like terms here. So it's going to give me x squared minus x minus 20. And this is my function in standard form. Okay? Hopefully, I know it's a lot of information at once, but it just takes practice, and we'll take some time with that. Okay? Stay on if you have any questions. Other than that, I'll give you the check-in code and get you out of here.